Hello, I'm Bob Kirkwood with Integration Guard, here to show you how to update IGES geometry in MasterCAM for Solidworks. The same approach works for STEP and other neutral formats importing a dumb solid. You will see that the geometry updates with all associativity intact, in other words, sustained integration. I'm going to show the integration 2 times, first quickly, then in full detail. Here we see a simple NC program for one orientation of a casting, just some simple drilling and facing. The most pronounced change will be a move for this 6.35 millimeter hole. Some other holes are shifted 1 diameter to the right. We switch to the imported component part and update the reference part via DCV replace. After the replace, most of the toolpaths are set to invalid, so we update those. And there we see our hole locations and a facing operation for the NC machining have been updated. Let's go back and look at the step where we actually executed the replace. You can see an entire body represented as a single entry in the feature tree. That tells us it's a dumb solid, probably imported from an external source. To go through this again in greater detail, we'll close out of this work without saving it, then reload the files. We open our new model by opening the IGES file. Then we immediately save in Parasolid XT format. We can close out of the file we just opened. There would be no harm if we chose to save that as a solid part file, but we don't need it, so we just close without saving. Our first step with DCV does a customized export of an XT file. That export preps the solid so that the replace to follow later will work properly. We export as sample 0. The export, upon completion, launches DCV to lead us through the task of recognizing the difference between sample 0 and our new version, sample 9. The first thing we see is that DCV offers as matches all the geometry that is exactly the same between the 2 versions. There's many ways and reasons we might choose to interact with the change recognition in a semi-automatic manner, but for our purposes here, we'll just tell DCV to automatically recognize all the geometry changes. At this point, we see DCV has proposed all possible matches. One unmatched face remains in the new version, and we'll tell DCV to consider that a newly added face. With this last step, all the geometry is matched. Let's examine some of the design changes more closely. We'll start by examining this selected hole. For starters, DCV doesn't see it as a hole in the feature sense. It's just a cylindrical face. Note that the identifier for that face is 484. The identifier for the matching face is 24F. Upon export-import, identifiers like that get resequenced. DCV untangles the effect of that resequencing. We capture and preserve that untangle by assigning matched names to all the faces and edges. You can see here that our selected face has a name, 12E. That was assigned in DCV's customized export. The name is distinct from the identifier, even though the displayed formats look similar. DCV will copy that name to the matching face in our new part. Let's take a brief detour and examine what edits have been recognized by DCV. We highlight in purple a 15 millimeter face move in the direction of the x-axis. We see in orange a 10 millimeter edit in the same direction. There's plenty of other edits captured as well. The point is that you have the information here to fully reconcile with your ECO. There's lots more here that might be shown, but it's not the topic for this video. Now we save the design change vector. Part of the save offers to transfer the names for our faces and edges to the new import. Next, we do our replace. Going back to the NC program, we see that our MasterCAM geometry needs yet another update. And there we see the new geometry updated. Let's examine the 6.35 millimeter drilling more closely with another simulation. The hole moved properly because DCV restored associativity. The collision shows some visible integration, but as a matter of full disclosure, there's no associativity involved in that. MasterCAM did not automatically recognize and drill our new hole, and that's to be expected. We can recall, though, that DCV did bring the new hole to our attention. To handle the new hole, we go into the geometry item and select the new edge. The new hole would work pretty much the same if the new part had been a native edit in Solidworks. You may have noticed that the update was done over in this separate part file. I believe that is considered best practice for Solidworks. If your dumb solid was located within your master file, the process would still work, but it would need to be repeated for the casting. This same technique works for a variety of downstream applications like FE meshing and tool design. You can use these DCV techniques to assure sustained integration with your customers regardless of their native CAD format and for recovering many cases of broken integration. For more information, go to integration-guard.com.